Hello, everyone. My name is Sanjana, and my favorite planet is Neptune.
Hi everyone, my name is Ritu, and my favorite planet is Saturn because of its cool rings.
And I'm Veronica, and my favorite planet is Mars because of its potential signs of life. And we are all from an amazing organization at UCLA called Interaxon that strives to make students like you more interested about the brain. Today, we will be talking about neurodegenerative diseases. This is such a big word, so let's break it down. Neuro, degen, tive. Does anyone know what are neurodegenerative diseases? Let's take some time to think about it and pause here if needed. Keep in mind throughout the video, we will be asking questions and giving you activities to do. Feel free to pause whenever you need to. Well, do you have some ideas? Great, let's keep those in mind as we discuss the definition.
Neurodegenerative diseases have a lot to do with the concept of neurodegeneration. Let's break that big word down too. First, we have neuro, which means brain, and then we have degen, which means decay. This breakdown helps us see that neurodegeneration is the progressive loss of structure or function of neurons, which includes the death of neurons. Neurodegeneration can be caused by many different things, including a buildup of proteins in our brain or cell suicide, which is called apoptosis. These diseases can grow over time, meaning that they can spread to more parts of the brain gradually until your whole brain cannot function properly, and it's really hard for a person to live. Now, look at this image here on the right. We can see that over time, the blue color spreads all over the brain, and this is an example of what a neurodegenerative disease might look like. So, there are so many different types of neurodegenerative diseases. Can you name some? Pause and think. Well, today we'll be talking about dementia, Parkinson's, as well as Huntington's. If you got those, great. And if not, that's okay. We can go through them together. First up, we will be talking about Alzheimer's disease. Alzheimer's disease, which I'm sure many of you guys have heard of, is a disease that affects the brain tissue of your cerebral cortex. It is known as the most common form of dementia, and dementia is the decline in mental ability. Do you have a relative or friend that you know that has Alzheimer's disease? Please think about that and pause the video if you do. Some symptoms of Alzheimer's disease are as shown here. The main one on the right, we can see an old man wondering about how to put the pieces of his puzzle back together. And this indicates something called memory loss, where you can't remember basic things. Then we also have trouble with orienting oneself. So basically being aware of your surroundings and understanding where you are. For example, if you were at school, normally you would know, okay, I'm at school versus I'm at home. But those with Alzheimer's disease have struggled with understanding where they're located. Next, we have the reduced ability to have a good judgment and good reasoning in your decisions. For example, for us, the normal kids, for now, we have the example of eating healthy because that's something that's good for your body and good for your brain. However, somebody with Alzheimer's might not have that good judgment and might still eat very harmful foods for their body. Next, we'll be talking about the causes of this dangerous neurodegenerative disease. We can see here the brain on the right has decreased tissue and brain matter in an AD patient versus a normal patient. There is something called a tangle that's present inside of these neurons, and it's made up of something called amyloid plaque. Can everyone pause the video and say amyloid plaque 3 times to themselves? Amyloid plaque is something that can be considered a gummy bear. Gummy bears are sticky, chewy, and most importantly, they can prevent things from going inside or through them. And if you think about it, if there are many gummy bears that are reducing communication between two things, then one person cannot communicate with the other, which is similar with neurons, as these two neurons can't communicate because there are so many gummy bears in between them. We can also see a picture here of the tangles present in an Alzheimer's patient versus a normal patient with our green plaques here. We also mentioned that there's something called atrophy, which is the loss of muscle and brain tissue, which is present in Alzheimer's disease. And we have large holes in our brain with fluid, which are also shown in that picture on our right. Next, we'll be talking about some treatments for Alzheimer's disease. While there is no definitive cure, there are many different treatments and medications that people can take to make them feel better and have a better quality of life. For example, one of them is called memantine. And also, listening to music therapy and doing puzzles and other cognitive activities can improve with the memory loss effects of Alzheimer's. Next, we'll be doing an activity, and be sure to tune in and join in with us on this activity. First, everyone grab a flashlight that you see around your house. I'll give you a minute to do that. Okay, now that you have your flashlight, take your flashlight and just like the picture shows, basically turn on that flashlight and see the light coming out of it. For example, this is my flashlight and this is the light coming out of it. Now, take your hand and cover the flashlight. What do you notice? Do you see any light coming out of that flashlight? Next, now think about the different components of this contraption. What acts as our neuron here? What are the gummy bears, so to speak? And what is the signal that needs to be relayed to the space outside of the flashlight? I'll give you a minute to pause and think about these answers yourself. Now that I've paused, I'll give you these answers really quick. So we can see what acts as the neuron is basically our flashlight itself that's trying to relay a signal by flashing its lights. The plaques and the fibers, which are our gummy bears, are our hand because they're covering and preventing that signal from getting out. And the signal itself is the actual light that's being relayed.
All right, so next up is Parkinson's disease. This disease affects the central nervous system, which includes all the neurons and structures located in our brains and the spinal cord. It is also a member of the movement disorder family because it impairs motor skills, speech, and other similar functions. So let's look at the symptoms of Parkinson's disease more closely. The primary symptom of the disease is the inability to initiate movement. In extreme cases, there can be a total loss of movement. Let's try an activity to illustrate this symptom. Place your fingertips on a surface. Now tuck your middle finger in so your hand looks similar to the one in the picture here. Now try to move each finger one by one. What did you notice? Was it hard to move your ring finger? This difficulty of starting movement is a characteristic of Parkinson's. Another symptom is a tremor, which is trembling in the hands, arms, and legs. You can remember what a tremor is because it sounds similar to trembling. Finally, another symptom is the inability to maintain fine control movement. These types of movements are very small but really important, such as opening your mouth or bending your fingers. Let's try another activity. Take your dominant hand and force your fingers together like the picture on the slides. Now, without bending any of your fingers or your whole hand, try to pick up your pencil. Did you do it? If you were, then that's amazing, because I wasn't able to. Another simple activity you can do to test your fine movement control is to try writing out a word, such as your name, with your non-dominant hand. Take a minute and pause here to write your name with your non-dominant hand. Is it as clean as you normally write, or is it a little shaky? Here are our attempts of doing the last activity. Was yours better than ours? Keep in mind how both these activities help to show that Parkinson's causes a loss of fine muscle movement. Now let's consider the causes of Parkinson's disease. One cause of the disease is a decreased stimulation of the motor cortex by the basal ganglia. As you can see in the picture of the brain, the middle region is where the basal ganglia is located, and it is responsible for controlling movement. Think of the basal ganglia as one star in a constellation and the motor cortex as another star. When connected, they form constellations such as a Big Dipper, but if not, then the constellation goes away. Similarly, if the connection between the basal ganglia and the motor cortex is lost, then there is a loss of movement. Another cause is a lack of the neurotransmitter, or a signaling chemical, in our brain called dopamine. Dopamine is responsible for movement as well. In this picture, we can see that the bottom part of the picture has less dots or less dopamine, and as a result, that causes movement disorders like Parkinson's. Other causes can also be head trauma or injury, and drugs, specifically like heroin. Let's end with ways to treat and prevent Parkinson's disease. One important method that helps treat Parkinson's and prevent it, like it helps with many other health problems, is exercise, as well as a healthy diet. One can also go to physical therapy to improve muscle movement or have surgery, specifically deep brain stimulation, where shocks from electrodes are sent in the brain to help stimulate nerves. Another important source of help is having a support system. Finally, another treatment option specifically to alleviate symptoms, not completely cure Parkinson's, is administering L-DOPA, which is similar to dopamine. Remember, when we talked about how Parkinson's can be caused by a lack of dopamine? Well, this treatment is useful since it can help replenish that lost dopamine. L-DOPA is also one of the oldest treatments for Parkinson's and is still used today.
Finally, let's take a look at Huntington's disease. Huntington's disease affects the cortex, which is the outer area of the brain, and the basal ganglia located in the middle part of our brain. Those impacted have difficulty controlling their movement because of a faulty gene in our DNA. This gene is autosomal dominant, so if just one person has it, as shown in the bottom left diagram, it will be passed down to future generations too. And the effects of this disease are actually really noticeable. As we take a look at the bottom right picture, the brain slowly deteriorates over time, and it looks much smaller, right? Now, let's check out this video explaining a little bit more about this disease.
Welcome to 2-Minute Neuroscience, where I explain neuroscience topics in 2 minutes or less. In this installment, I will discuss Huntington's disease. The symptoms of Huntington's disease typically emerge during middle age, and at first often involve subtle changes in personality, cognition, and movement. Eventually, the symptoms progress into substantial movement problems, like chorea, which involves uncontrolled spasmodic movements, impaired coordination and balance, muscle rigidity, and difficulty speaking and/or swallowing. Cognitive and psychiatric symptoms like dementia and depression occur as well. The disease is incurable and fatal. These symptoms are associated with neurodegeneration, or the deterioration and death of neurons. A group of structures called the basal ganglia are strongly affected, but other regions of the brain experience neurodegeneration as well. The pathology of Huntington's disease can be traced back to a mutation in a single gene called Huntington. The mutation that causes Huntington's disease is a dominant mutation. Thus, if one parent has the disease, their child has a 50% chance of developing it too. The Huntington gene contains a DNA sequence that consists of 3 nucleotides, cytosine, adenine, and guanine, in repetition, a pattern known as a trinucleotide repeat. When the gene is mutated, an excess number of repeats can occur, and a mutated form of Huntington protein is created. The higher the number of repeats, the greater the risk of disease, and all people with 40 or more repeats in the Huntington gene will develop Huntington's disease. Mutated Huntington proteins have a tendency to group together, forming clusters within neurons that are not easily removed by brain enzymes. It has been hypothesized these clusters may play a role in the neurodegeneration seen in Huntington's disease, for their accumulation in the brain is associated with increased neurodegeneration.
Some symptoms with Huntington's include irritability, like our red angry bird in the top right, being clumsy, like this Smurf in the left, trouble with learning, not walking normally, and getting injured often. So, is there a way to treat this? So far, there hasn't been a breakthrough yet, but there has been significant progress made as we learn more about Huntington's. Who knows, maybe you will be the first one to find a cure. Currently, exercising and staying in shape are known as the best ways to help slower its development. As you probably have noticed, there are a lot of similarities between Huntington's and Parkinson's diseases. Let's test your knowledge. Can you fill in this Venn diagram? Pause this video and try to solve it. Here are the answers. The lack of dopamine and inability to initiate movement goes into Parkinson's, both known are as movement disorders, and using exercise as treatment goes in the middle. And finally, the hereditary and can't control movement go into the Huntington section. Great job, everyone. We would like to thank you all so much for watching and learning more about neurological diseases with us. If you would like to learn more about our organization, please visit the first link at interaxon@ucla.org and check out more videos in the second YouTube link. To conclude this presentation, I am leaving you all with my attempt at the earlier Parkinson activity with a drawing of an ice cream. Take care, everyone.